Okay, so something bad happened, and we're going to talk about it in this video. And the bad thing that happened is I was looking at this Electfreaks Wukong expansion board, which is very, very nice, and it has a built-in battery, and you can charge that battery, and it has a push button to turn it on and off, and it's got 8 servos, 2 motors, some of the pins here. It's got I2C output, everything you'd want in an expansion board. Plus, look, it fits onto Lego blocks, so everything you could possibly want an expansion board. And I have burnt it. I broke it. So what I was trying to do is figure out what voltage was being applied to our servos when using this board, and to see what impact different inputs, power inputs, would have on the output. And I put 5 volts onto the input here, which is a USB mini port, and it was 5 volts, but I smelled it burning, and that's not good. When you smell something burning and you don't actually have a fire going anywhere, that's just not good. So what happened is, when you turn it on, it blinks and then it turns itself off. So this is now broken, which is unfortunate, because I kind of like this board if it hadn't gotten burnt up. Alright, so let's put that aside. Now, I do have other boards, but I want to show you something different today. And the thing I'm going to show you that's different is, what do you do if you don't have servo outputs and you need a bunch of servos? Now, the microbit itself will do servos, but it won't do a lot of servos. If you use specific pins 0, 1, 2, and 3, it has a better chance of doing all 4 servos. But some of the documentation says it really doesn't like to do 4 servos at a time. So what I'm doing instead is I'm running a board. This is a breakout board. So what I'm doing instead is I'm running one of these boards. And these boards are like real cheap. So for a few dollars you can get one of these boards, and it has on it right here this chip. And that chip is a PCA 9685 chip, which does pulse width modulation. And it's got a couple places where you can put the voltage in, and this connects via I2C, which stands for inter-integrated circuit. So a lot of chips will have this I2C interface, or IIC. Some people call it I2C. You'll see it in writing as I2C. So I2C. And I got these $12 for 2, so $6 each. And here I've got it on a breadboard, but if you have, now here is a Key Studio sensor bit, and the sensor bit has I2C output. Yes, it does. Right there. I2C output. Which means that you can connect it to one of these boards that has 16. Look at those, 16 different servos it can run. Here's another board. This is an Electfreaks board, but as you can see, it has ICC outputs, 2 of them, right there and there. Different ones, male, one's female. And so by giving you access to all the pins, you can connect something to an I2C network. Now, even this, I like this. This is kind of a nice little gadget. It's from Pimoroni. It's called a bit between. Is that what it's called? Yeah, I think it's called bit between. And what it does, no, wait, pin between. It's called pin between. Okay. And what this does is it allows you to connect your microbit to one side and still have the connector so that you can connect it into another board as well. So let's say you have something like a hummingbird board, which doesn't really give you access to all the pins. You can use something like this to get access to all the pins and have the hummingbird bit board connected as well. So you get the best of both worlds from this. You can have a board and then you can have all your connections. So, for example, you could use the IoT board, which has wireless connections, and still have access to all the pins. So, how do we connect it up if we've got all the pins, or we've got a specifically broken out I2C? Well, the pins involved are 19 and 20, and plus 3.3 volts and ground. And when you get it connected up, so as you can see here, what I've done is I have plugged in a battery. This is 3 AAA batteries, which means I'm looking at about 4.5 volts coming out of this, and which is close to 5. And this particular Key Studio board, breakout board, and breadboard, this comes as a set, which I like. You get this, you get all that, and you get a bunch of other components that you can use, one of which is a servo that you can try out. So what I've done is I've connected pin 19 to, pin 19 goes to SCL on this board. It'll say right on the board, I'm going to use my magnifier, SCL and SDA, along with ground, an OE pin, which we don't want to use, and a VCC pin. Now VCC is the voltage we want to run this circuit at, which is different from the voltage we want to run our servos at. There is a V plus pin right on the end there, and that and this here, you can use these clips and you can put in a different voltage to run the servo. So when this circuit is working, this is an oscilloscope, and it shows us the output from the servo control signal, and you can see that it's using pulse width modulation. Pulse width modulation. So as we request a larger angle, we see that that pulse gets wider. And if when we request a smaller angle, it gets shorter. So let's plug in our servo now. And now we can see it moving our servo. And we can go back to 90 degrees. Okay, so this is another way to connect servos if you don't have actual servo connections, like some of the boards we have do not. Okay, thanks for watching.